Welcome to lesson number 2 on exponential function unit, the first unit of our MCT4C course. Today's goal is to review the exponent laws, and by the end of today's lesson you should be able to apply the basic exponent rules to questions that contain integer exponents. So we've got a couple of years behind us in terms of being able to do these things, so we're just going to review quickly here the different rules. The first law is the multiplication law. So what it says is if our bases are the same, so let's say we had a to the exponent m and we're multiplying it by a to the exponent n, the rule is the base stays the same. The base will stay a. It doesn't become a times a, it's a. But what we do is we add those exponents together. So you should know that from your grade 9, grade 10, grade 11 review. All right, so if we do some examples here, I don't have the same base when I look at the 5 and the 2. They're different bases. They're just different numbers. Those could just get multiplied together. So 5 times 2 gives us a 10. And then x squared times x to the 4. X to the 2 times x to the 4. Those bases are the same. The base stays an x, and then I add the 2 and the 4 together to get 6. All right, try part B. You can put this on pause, give it a try, and then you can check it. All right, so 2 times negative 4 should be negative 8. So negative 8 for that. We have an x to the 1 here. The 1 wasn't written, but there is a 1. And then an x squared here. So altogether you've got 3 x's being multiplied, or x to the 3. You then have y squared times y cubed. Altogether you've got 5 y's being multiplied. So that's a y to the 5. All right, similar rule for division when your bases are the same and you're dividing. The base stays the same, but this time instead of adding, we're going to subtract, because subtract's the opposite of the adding, just like division is the opposite of multiplying. So we get a to the m, take away the n. All right, so again, 6x cubed divided by negative 2x squared. We divide the actual numbers together, so 6 divided by negative 2 would be negative 3. And then an x cubed divided by x squared, the 3 take away 2 would just be a 1, and we don't normally write the 1 in. It's just a minus 3 times x, or minus 3x. Part B, negative 28 divided by the negative 4 would be a positive, and 7 is the number. We have an a squared divided by a squared. So 2 take away 2 would be a 0. A to the exponent 0 really is a 1. But how you can think of that is any number divided by itself. So a number divided by itself always just answers to be a 1. Right? So 7 divided by 7 is 1. Negative 23 divided by negative 23 is 1. A squared divided by itself, a squared, is 1. So I'm not going to write that in. Well, I will, but I wouldn't normally write that in. So I have a 7 times 1 times, and then we have a b to the 4 times a b to the 1. Just keep the base a b, and then 4 take away 1 would be a 3. So my final answer, or the better answer for that, would be 7b cubed. So only the b is getting cubed. The 7 doesn't have the cube on it. All right, part C, the power of a power rule, says if I have a power, so a base with an exponent, so a to the m, and then that has another exponent on the outside, like an n, the rule is that those exponents get multiplied together. So your base stays the same, but you're going to have m times the n. All right, so if I have x cubed all to the 2, keep the base an x, and then 2 times 3, or 3 times 2, is 6. So x to the 6. All right, part B. Now, this gets a little trickier because everything inside the bracket, the 4, the a, and the cubed, all get the exponent of 2. So you can think of this as 4a cubed times 4a cubed. Now, I wouldn't normally write this out, but I'm just going to for my explanation here. So what I really have is the 4 times the 4, or the 4, let me grab a different color, the 4, which has an exponent of 1, that 1 gets multiplied by the 2 on the outside here. So 1 times 2 really means I have a 4 squared. Again, I wouldn't necessarily write that step in, but I'm just trying to explain what's happening here. And then we have an a cubed, so the 3 gets multiplied by the 2. We're going to have an a to the 6. So we can either think of it as 4 times 4, or we can think of that as 4 to the exponent 2. But in the end, your final answer, and you could directly go to this final answer, should be a 16, and then an a to the exponent of 6. So the 2 times 3 gave us 6, or 3 plus the 3 gives us 6. All right, so the green answer is the final answer, and you could go directly to that final answer. So try that with C, see how you get along. Experiment with D, put the video on pause, and then press play to check. Okay, so if I'm cubing, my exponent is 3 outside here. I'm going to have a negative 2 times a negative 2 times a negative 2. So 3 negatives being multiplied together will be negative. 2 times 2 is 4 times 2 is an 8. So negative 2 all cubed is negative 8. We now have our x to the 4, which then becomes, when I cube that, becomes an x to the 12. And then the y to the 1 all to the 3 becomes a y cubed. So final answer is negative 8 x to the 12 y cubed. Next one we have, everything in the bracket gets the exponent of 4, so these get multiplied together here, and these get multiplied together here. So you should get an a to the 16 divided by, now this negative also gets the exponent of 4, so negative times negative times negative times negative is positive overall, so it will be a positive answer, and then b to the 12. 3 times 4 is 12. Hopefully that makes sense, and we'll go to the next part. Okay, the zero exponent I already mentioned already. If you have, for example, when we had the a to the 2 divided by a to the 2, that really gave us a to the 0. So I'll just put that, actually, let me undo that. All right, and I'm going to make it more generic. A to the m divided by a to the m. Any number divided by itself will just equal a 1. But if I look at that as an exponent rule, a to the m divided by a to the m, divided by a to the m, that's going to equal a to the 0. So the final rule, the overall riding rule here, is that anything to the base, to the exponent of 0, any base to the exponent of 0, will equal or evaluate to be just a 1 on that. Okay, so looking at our examples here, all of this is the base. That whole thing is to the exponent of 0. That all that I've circled in blue will become just a 1. All right. In the second example, the only thing that's getting that exponent of 0, let me try that again, is the y. That's the thing right next to the exponent of 0. So we have 3 times y to the 0. The y to the 0 becomes a 1. 3 times 1 is 3. All right. The last example here is our negative exponent rule. It's a little trickier again as we go through this. Let's take a look at some examples here. If I have a to the exponent negative m, we talked about that as being, change it to the reciprocal and make the exponent positive. Okay, the reason that works, let's say, I'm just going to jot this down here. If I had a to the 5 divided by a to the 7, if I use my exponent rule, that gives me a to the negative 2. Okay, so 5 take away 7 gives an exponent of negative 2. I could also look at this as a to the 5 equals a to the 5 divided by a to the 5 times a to the 2. So what I've done is I've broken this a to the 7, change some color, broken the a to the 7, there we go, a to the 7 has become, 7 really is the same thing as 5 plus 2. The reason I did that is so that you can see if I have a to the 5 dividing by itself, they cancel each other out just to become a 1. Okay, we're going to get 1 overall. Oops, doing something there. Okay, so they cancel out to be a 1. That leaves me with a 1 over, and then 1 times a squared on the bottom is just a squared. So overall, my a to the negative 2 equals 1 over a squared. Okay, so a to the negative 2 that I had right here is equivalent to 1 over a squared. So that's what I have written in terms of that. I could further that understanding. If I wrote it as 1 over a to the negative m, it follows that that is the same thing as a to the positive m on the top over 1, or just a to the positive m. Okay, so we developed these rules in 3M math. Hopefully you remember them. If you're struggling with them, if you want more explanation on them, please ask me for that, and I will try and do my best to help you out with that. All right, my last part of the negative exponent rule, if I had a fraction of a over b to the negative m, really that's going to give me a to the negative m over b to the negative m, and then the a and the b switch spots. So the quick way of doing that is to say that that's going to take the reciprocal, switch their spots, and the exponent becomes a positive m. Now the negative exponent rule I always leave for the last. I try to do every other exponent rule that I can first, because sometimes in doing so I get rid of negative exponents and then I don't even have to deal with these crazy rules. Okay, so I'm just going to outline the fact that we really have kind of three parts to it. We've got this first part, we've got the second part here, and we've got the third part here. Okay, write with a positive exponent. Final answers should be kept in fraction form. We've got some examples here. So the negative exponent rule says that I could rewrite that as 1 over 4 to the positive 2, which would be 1 over, and then 4 squared is a 16. Okay, part B, the only thing that has the negative exponent is the y. So the 3x to the 4 stays where it is. It doesn't slide to a bottom or anything. It's just the y is going to slide to the bottom, changes position, and its exponent becomes positive. All right, and part C, I'm going to actually divide these numbers. 6 divided by 2 is a 3. I'm going to take care of my, I have nothing to simplify there, sorry. My a is to the negative 3. It's on the top. I'm going to slide it down to the bottom. It becomes a to the positive 3. My b squared, right here, is a positive exponent. It stays where it is on the top. On the bottom, I have an x to the negative 5. It has a negative exponent. It's going to slide up to the top, and its exponent becomes positive. And then the y to the 4 was on the bottom, and it was a positive exponent. It's going to stay on the bottom. So now I've re-expressed that with final answers being only positive exponents and in fraction form. So give the next page a whirl, and then you can move on to video 2 to check your answers, or you can just start with video 2 on the second page and work through more examples